All right, last example, section 3.2. Let's look at the Newton's law of cooling model. All right, so the temperature of a cup of coffee T minutes after it is poured is given by this function. Okay, capital T is measured in degrees Fahrenheit, and lowercase t is, of course, time in minutes. So letter A, what was the temperature of the coffee when it was poured? Okay, so when a cup of coffee is poured, that's like initial. That's T equaling 0, all right? No time has passed when the cup of coffee was initially poured. So what you will do here is, looking at this as a function, it'll be the temperature after 0 minutes. So immediately, or initially after the coffee is poured, you would get this. And you could use your calculator if you wish, even though this one really doesn't require a calculator because T is 0. So if this is 0, any base e to the 0 is 1. 100 times 1 is 100. 100 plus 70 is 170. So the temperature here would be 170 degrees Fahrenheit. That's the initial temperature of the cup of coffee immediately after it was poured. All right, letter B, a little bit different. When, so now we're trying to solve for T. When will the coffee be cool enough to drink, say, 120 degrees Fahrenheit? I know for me, I wait 10 minutes before I even begin to drink a cup of coffee when it's freshly poured. So, well, we do what? We know the temperature now, it's 120, so we replace capital T with 120. We set that equal to 70 plus 100 e to the negative what? 0.0446 t. So now we're solving for t. All right, we have an equation. This is similar, actually, to the last example we looked at. All right, so what are we going to do here? I'm going to first subtract 70 from both sides. If I subtract 70 from both sides, I now have this. And then I would do what? I'd get rid of this 100, and I would do that by dividing both sides by 100. So now I have what? I have 1/2 is equal to base e to the negative what? 446 10,000ths. Blah. Okay. Now, what did we do? What's the trick here? What did we do in the previous example? We have base e to the something. How do we get this something out of the exponent position and into the numerator? We take the natural logarithm of both sides of the equation. I don't know what I did that for. The natural logarithm of both sides of this equation. Because when we do that, ln of 1/2 stays on the left for now. When we do that on the right, the ln of e to the anything is equal to that anything. You got to get that. All right. Now it's just a matter of using our calculator to divide both sides by this coefficient here. Coefficient of t to give us t alone. So let's see. Let's take this out to the nearest tenth of a minute. The tenth of a minute. So let's see what we can do here. I'm going to do the ln. See if you can see that. ln of 1/2. The ln of 1/2. And I'm going to divide that by what? I'm going to divide it by negative 0.0446. And I get about 15.5 minutes. Do you see that? 15.5 minutes. So I'm going to write down 15.5 minutes. Okay, that completes the notes for section 3.2. I'll see you shortly, I hope, for the notes in 3.3. See ya.